Hello everyone. Today we are going to discuss about our project Evolutionary Algorithm for playing checkers game. So motivation for our project. So reinforcement learning. Efforts in machine learning have been often aimed at reinforcement learning where a series of action leads to success or failure and some of the credit or blame for the final results can be traced back to each action. In a game of strategy, such as checkers, the final result of win, lose, or draw is associated with numerous decisions made from first to the final move. The credit assignment problem then has been to find rules for rewarding correct actions and penalizing incorrect actions. So, to do this, we need human expertise for our strategy games. So, there are algorithms that can play checkers game with using human expertise. We are trying to implement a self-learning evolutionary algorithm to play a game of checkers without relying on any specific credit assignment algorithm and also without relying on human expertise. Our solution approach. So we use information, only the position of pieces on the board, spatial characteristics of the checkers board. And this information is then given to the neural networks. These neural networks, we use neural networks as the evaluation function. The evaluation function will give us um, the possible next move a player can make. So EA optimizes the population of neural networks that are used to evaluate the worth of alternative potential positions. The level of play is attained without using any features about the game that would require human expertise. So here is a sample representation of the board. So checkers board is 8 cross 8 board. Each checkers board was represented by a vector of length 32, with each component corresponds to an available position on the board. The vector of length 32, this vector is given as the input to the neural network. Components in the vector can be 1 for 1 indicates a black or red checker and -1 for the white and 0 for the empty square.
So now we have a look about a neural network structure. The artificial neural network used to represent checkers playing strategies. The network served as a board evolution function. Given any board patterns as a vector of 32 inputs, the first hidden layer assigned a node to each possible square subset of the board. Each available square in a given subset was assigned a weighted connection, and the dot product of the weights and elements in a available square was filtered through a hyperbolic tangent function. The output from these nodes were then passed through two additional hidden layers of 40 and 10 nodes, respectively. The final output node was scaled between -1 to 1 and included the sum of the input vector as an additional input. All of the weights and bias terms of the network were involved. The flowchart shown here is pseudocode of the genetic algorithm that we used in the project. First, we will initialize the population, for example the neural network, and have them compete with each other, and based on their performance, we score the neural networks. Then, we check if the generation is more than 100, and if it's true, we stop. Else, the neural network are given to selection operator, which selects the parents of creating offsprings. We used ranking order selection operator to score the parents and create offspring with top 15 ranking. Then we used crossover and mutation method to create the offspring, and also G, that is generation count, is incremented by 1. This execute until G is less than 100, and once G is more than 100, the algorithm stops. And in a conclusion, we started with 30 players. The neural network, which is used as an evolution function, is involved over 100 generations. After 100 generations, the algorithm is decent enough to play, and it all learns the game by itself without human expertise.
Now we'll take a look at the implementation code. Here is the code. So the checkers.py. So this is the game engine code. It has all the rules of the games and possible moves, legit moves. And so there is a separate Python file which has functionality to predict the next move. Here is the neural networks. So we initialize the neural networks with initial weights and biases, and this will give us the next possible move. And the board is initialized with these values. As we said earlier, 1 is for the red or black, and -1 is for the white, and 0 represent empty square in the board. So we initialize the board, and then we initialize the play. As we said, we select 30 players to play against each other, and so this continues for 100 generations. So I have a demo code ran. So this was the code that I executed, and here is the output that I have received. This is the total time taken by our algorithms for 100 generations. As we can see here, after each and every move, a board will be updated and is shown here. So, and also we have for the demo, we have considered two CPU players, that is both white and the red players or CPU players, both will be played by CPU. And at the end of the game, the result of the game will be displayed, whether it's a draw, win, or lose. So, and we see here there are 8 rows. 8 rows corresponds to the 8 rows of the checkers board, and the X marks include these X crosses are the uh, positions of the white, and 0 is the positions of the black or red. So this is the sample demo. Thank you for watching the video.